All right, today we are going to do the paper 2 from June 2024, the paper which was written as supplementary. We are going to concentrate on Euclidean geometry. So if we are to check the question that we are having here, question 8.1, we are told in the diagram, chord AB, BC, and AC are drawn in the circle with center O. Then you are also given that DC is a tangent to the circle at C. Prove the theorem which states that the angle between the tangent to the circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. That is, you are required to prove that BCE, this is BCE. Our BCE, if we are to check this angle, you are required to prove that BCE is equal to angle A, is equal to angle A. You are required to prove that BCE is equal to angle A. So, how do we go about doing it? Number one, always when doing proofs, the first step that you have to know, you have to construct. So, in this case, we are going to construct radius, OC, and radius OB. Then what you do, you have to write it. So we are going to say construct radius OC, it's radii. Okay, and radius OB. Then from there, as we can see here, what are we going to conclude? What are we going to conclude? In this case, what are we going to conclude? We are going to conclude that angle OCE is equal to 90 degrees. Sorry. Okay, it's fine. We are going to conclude that angle OCE is equal to 90 degrees. So we are saying this angle is 90 degrees. So we are going to write that angle OCE is equal to 90 degrees. Why are we saying it's 90 degrees? Always tangent is perpendicular to radius. Tan perpendicular to radius. Then from there, we can now calculate the angle OCB. So it means our angle OCB will be equal to the 90 degrees minus the angle BCE, minus angle BCE. Then from there, you are also supposed to take note that OC is equal to OB. Why are we saying that? They are both radii. They are both radii. So this angle and this angle are equal, because this side and this side are equal. So we are saying OC is equal to OB. They are both radii. Then you go into triangle OBC. You'd realize that the angle OCB will be equal to angle OBC. So OCB is equal to angle OBC. Why? These are angles opposite equal sides. Then from there, in this triangle, we can calculate the third angle, which is angle O. It's angle COB. So we can say angle COB plus angle OCB plus angle OBC must be equal to 180 degrees. What is the reason for that? These are angles in a triangle. Then let's calculate our COB. It therefore means our COB will be equal to 180 degrees minus OCB, but we said OCB is 90 degrees minus BCE. Minus again OBC, but we said OBC is equal to OCB. Therefore, OBC is also equal to 90 degrees minus BCE. When you expand, it therefore means that the COB is equal to 180 degrees minus 90 degrees here plus BCE minus 90 degrees plus BCE. So it therefore means that our COB will be equal to 180 degrees minus 90 degrees minus 90 degrees get 0. Then we are left with BCE plus BCE, which gives us 2BCE. Then we now know that this angle is equal to 2BCE. 2 times BCE. We can now link this angle at center with the angle at the circumference since they are both subtended by BC. So we can now say our angle COB is equal to 2 times the angle A. Why? Angle at center, angle, okay, let me write proper it. We are saying angle at center is equal to 2 times angle at circumference. Then from there, since COB is equal to this and COB is equal to this, we can therefore conclude that 2 times BCE is equal to 2 times the angle A. Divide both sides by 2 Therefore, we are left with the angle BCE being equal to the angle A. Means we have proven the theorem. Right. Alternatively, if you want to prove that this angle, you want to prove that the angle BCE is equal to angle A. So, alternatively, we can construct a diameter. We can construct a diameter from C. We can construct a diameter from C. We can construct a diameter from C up to a diameter which we can call CM. Then construct a chord AM. So write what you did. So construct diameter CM and chord AM. So in that regard, we can now come and say angle M. We can now come and say angle MCE. Angle MCE is equal to 90 degrees. What is the reason for that? Is tangent, this tangent DE perpendicular to diameter. The diameter that we constructed, CM. Therefore, we can now conclude that therefore the angle BCE will be equal to 90 degrees minus the smaller angle, this one, which is angle MCB. Then we go in triangle CAM. We can conclude that angle CAM is equal to 90 degrees. Why are we saying CAM is equal to 90 degrees? It's an angle in a semicircle. It's an angle in a semicircle or angle subtended by diameter, because this angle is subtended at the circumference by diameter CM. Then from there we can conclude that the angle A will be equal to angle 90 degrees minus MAB, minus the angle MAB. But our angle MAB is equal to our angle MCB. What is the reason for that? If we check, these two angles are subtended by the same arc or the same chord BM. The reason, these are angles in same segment. Therefore, we can conclude that this 90 minus MCB is the same as 9, is equal to 90 minus MAB. Therefore, our angle A in this case will be equal to our angle BCE. Has been proven.